Question 6, as we did in the last paper, what you do, we take log of both sides. I get log raised to 5x is equal to log of 20. All right. Then carry the x over to the front here now. I get x log 5 is equal to log 20. So now to solve for something like this, what we're going to do, we're going to divide both sides by log 5. So we're going to get that x is equal to log 20 over log 5. And so your answer is in fact C here. We did this question, these few questions in the last paper. So again, the only way in which you can apply your law of logarithms, in particular the law that says log of m plus log of n is equal to log of mn. The only way you can apply this law is if the value in front of the logs here are both 1. So what we need to do, guys, we need to change it from 3 and we need to change it from 2. It's not like we can just divide it by 3 or anything like that. We have to use a law of logarithm, right? So we're going to use the law that says log of m to the p is equal to p log of m, and we're going to reverse it. So what it's saying here is that you can move the power to the front and you can move it from the front to a power. So when we get this 3 here at the front, I can move it up top. I'm going to get log of x cubed plus move this 2 to the front now. It gives me log of z squared. Now, because the value in front of them is 1, there's no other number there, so it has to be 1, then I can apply the law here. So what I'm going to get, I'm going to multiply it as x cubed times z squared, multiplying variables, so write them together. The answer here would be B as in boy. All right, so that's warm up. Ready? So let's get into it even further. So when I look at question 8 here now, which of the following is not true? We went through it before, and I did indicate to you that whenever we're setting questions, we always set this as a trick question. Now, how did we know it's trick? If you remember, ln of x plus ln of y is actually equal to ln of xy. A lot of you will be tempted to say, oh, we can just distribute the ln, so ln x, ln y. Nope, that's wrong. You can't do that, all right? So you have to remember your basic law of logarithm here, and this one will indicate to you whether it's true or false. All right, which of the following best describes the graph of y equal ln x? I already know how y equal ln x graph looks. We draw it in the first one. So it's always like this, and it is asymptotic to the negative y-axis. So all you have to do is just look for which one it is. So it's definitely not this. This is y equal a to the x. It's not this one here. It seems like this, but let's double check with all the other options. It's not this, and it's not this. So the only answer here would be, in fact, C. All right. So I'm told that you're not getting sequences, so I'm not going to sequences here. You're not getting. I'm told that you're not getting sequences. Not doing that. Not doing summation because that's a part of sequence as well. All right. So let's come down here. So what value of m will make this singular? We did it in the first paper. So, hey, Nastasia, could you mute your microphone, please? Hey, Nastasia, could you mute your microphone, please?
Bomba, my ear.
All right. So what value of m will make the matrix B here a singular matrix? So when our matrix is singular, we defined it that the determinant has to be equal to 0. And we also defined the determinant to be the product of the leading diagonal, so we'll go down, minus the non-leading diagonal, which is going up. So let me just clear that up for you. Ready? So what we're going to do, we're going to say that the determinant of B, because it's singular, the determinant of B is equal to 0. But we also know that the determinant of B is going to be the product of the leading, which is going to give me 2m, minus the product of the non-leading, so 3 times negative 2 will give me a negative 6 there. So what we know now, it implies to me that 2m, now when I have a minus minus here, that gives me a plus, so 2m plus 6 is equal to 0. What I'm going to do now, I'm going to solve for m. So to solve for this, I need to carry the numbers on one side. So that gives me now 2m is equal to -6. Solving for m, what I'll do is divide both sides by 2. I'll now get that m is actually equal to a -3. So this here is the answer. Now, we worked this out before and we said that the determinant was 0. How did we know this? So we use that property that you cover one number. So starting with this here, 0.72, right? I'm going to cover the entire row and cover the entire column. And then what's going to happen is I'm going to multiply this number. So 0.72, I normally call it our pivot value. So I'm pivoting on 0.72. And then I'm going to multiply it by the determinant of the inside value here. Now what's going to happen here is that the determinant of this, 0 times this is 0. 0 times this is 0. So the determinant will be 0 there. Now, when we now move across any row or column, let's move across the row with zeros here. The pivot value is going to give me 0. So I'm going to have plus 0 times something. 0 times anything is 0. And then I pivot across now to this 0 is going to give me another 0. So you realize that the sum is 0 plus 0 plus 0, which is in fact 0 at the end of the day. But I'll demonstrate with a better example so you guys can actually know how to work it out. All right. Let's go down now to this system of equation. So they're asking you, if we use Cramer's rule, how can we actually solve for the value of x? Now, let me show you the steps as to how you do this. The first thing first is to write it as, write the equation as a matrix equation. So to pick up the matrix equation, what we're going to do, we're going to take the coefficients values, not the x or y, but what's in front of them. So in front of them now, I have a, and then I have b in front of y, and I have c down here, and I have d. Something that you should pay attention to is the order in values. So this is x then y, then x then y. So ensure that they're the same, right? So that's my first matrix. Then I'm going to have I have x, y here. Now the order in the values here is dependent on how you order them going forward. So here you realize that I start with an x and then I have a y afterwards. So you have to list them in that order. So x then y. Then I'm going to have equal E, F. Now, what we have here is a matrix equation in the form AX equals B, right? Now, Cramer's rule says to us that if I want to solve for x, x is going to be equal to the determinant of AX over the determinant of A. This is how we normally teach it. So, how do I know or how do I find what AX is? So, AX is the matrix that you get when you replace the X row by the solution matrix. So, what will happen now, guys? Ready? When I replace this column here, this is the X column, and this is the Y column, I replace the X column with the solution matrix EF. So it's going to give me the determinant now of EF. Then I'm going to have BD, but don't change it because we're only changing the X column, right? So that's AX. And how would I find the determinant of A? The determinant of A will just be the determinant of the matrix A here. So that's just going to give me A, B, C, D. So by Cramer's rule, if I wanted to find what X was, X would be equal to the determinant of AX. Let me just stop in back the determinant signs here. That would give me EFBD over the determinant of A, which is ABCD here. So that's what Cramer's rule says to us. So if I now wanted to say, find what X is, so we'll just look for the correct one. So no, this isn't the answer. EFBD, ABCD. This definitely is the answer. So our answer here would be B as in boy.
A few weeks to settle.
All right. So you're not getting limits as to what I'm told. You're not getting limits there. All right, cool. So given that we worked out most of the stuff, what I'm going to do now, I'm going to actually, for the next 20 minutes, I'm going to teach some stuff or some content from scratch and demonstrate with some examples. All right, so let me just close that screen there. All right. So I was browsing through your syllabus and I was looking at the content as stated under the different objectives. So I'm going to start with unit 3, right? And that would be equations. And this is just going to be a quick recap of the concepts because we only have 20 minutes left on this call. So I'm going to look at what your syllabus says. So on the equations, you need to have a brief review of linear and quadratic equations, right? So let's talk about what a linear equation is. So a linear equation is any equation where the highest power is 1. So the highest power of any unknown variable is 1. Highest power of unknown variable is 1, right? Is 1. And the variables, so the unknown variables are only added or subtracted and not being multiplied. Are only added or subtracted, So that means that you can't multiply or divide unknown variables, right? So let me give you a quick demonstration as to an example of a linear equation. Say if I have y is equal to 3x minus 1 here, this is linear. But how do we know it's linear? You just check the rules. So the rule says that the highest power of the unknown variable is 1. So the unknown variables here are y and x. If you realize it's just y to the 1 here, x to the 1, so that satisfies the first condition. Also, it says to you that you cannot multiply or divide. You can only add or subtract them, right? So when I add or subtract them now, you realize that there's no multiplication here. It's definitely linear. But what if I gave you, say, 3x is equal to xy? Is this linear? If you look at it, it's not linear because x and y are being multiplied, right? So because they're being multiplied here, this is what we call a non-linear equation. Now, this is usually a trick that I normally ask my students. Is an equation as 4 is equal to x over y linear?
No.
Is it linear?
No, because it's being divided.
All right. Now, here's a trick. Ready? You actually have to reduce this equation to one line. So if you realize up top here in the two questions up top here, right? If you realize there's no denominator going through the equation, you always have to write it in that form to tell whether or not it's linear. So to get this in one line, I normally tell students it's one line, meaning it just goes across, there's no denominator. I'm going to set it up and cross multiply, right? So this will be 4 over 1, cross multiply now, I get that 4y is equal to x. So when you look at it in the essence of one line, it is in fact linear. So to identify it, guys, you always have to get it on one line there. So you guys saw that trick there?
Before by multiplication.
So that's again? All right. So I hope you guys can remember that, right? Now, I'm not going to go in depth with solving linear equations because it's very simple solving linear equations. What you do for solving linear equations, you group the unknown variable on one side, and then the numbers on the next side of the equation. So when we talk about linear equations,
I'm sorry. Previously, when you were just turning it into a one line, didn't you just have to multiply to get it as a one line, though?
yes, I did. But the rule says that you're not supposed to be multiplying the variables. So when we multiply it across now, we're multiplying to reduce it, but we're not essentially multiplying the variables. So you get the difference there?
Okay, got you.
No problem at all. Thanks for asking. All right. So to solve linear equations, what you'll do, you would actually group the variables on one side, so the unknown variable on one side, and group all the numbers on the next side. So for starter, let me just start with an quick example here. Probably this is what I should have done for the entire class. So when we start with a simple example here, I'm going to say, for example, 2y is equal to 6. Just your starting example. Here, you want the variables on one side and all the numbers on the next side. So to get rid of this 2 here, you divide both sides by 2. You get that y is equal to 3. But that's a starting example, so that's really easy. But let's look at another example here, where I give you know that y minus 3 is equal to 2y plus, say, 7 here, right?